Today we are going to discuss about units and measurements, grade 11 and NEET JEE students. Okay, so right from basics onwards we'll discuss. Right from basics to advanced level we'll go. So one class I took based on the units and measurement. This is the second class. Second class I'm taking related to units and measurements. Second class I'm considering like this. Okay. I hope it is clear to you all. Visible everything. Right? Now it is clear. Units and measurements. Units and measurements. This topic, so I'll explain about fundamentals and including advanced level. Okay. So if you have any doubts in middle, so you can ask. So you can get the clarification. So if you have any doubts, you can ask immediately after completion of that. So in units and measurements, first we'll go with the what is quantity. Quantity. We'll start with the quantity. Quantity is nothing but quantity. Quantity. So if you go to shop and ask shopkeeper, I want rice. I want rice. So will he give immediately rice? Will he give immediately rice? No. He will ask two questions. For how much? For how much you want and how many kgs you want? For how much and how many kgs you want? Like that you will ask two questions. So units and measurements. Units and measurements. Measurements. So this topic will be helpful for so by Siva sir. So helpful for grade 11. Grade 11. So NEET JEE, EAMCET. Okay. So this topic helpful for these students. Okay. So now we are working on quantity. So what is the quantity? The quantity is nothing but, so if you are going to shop, quantity. If you go to shop and ask, so quantity. Okay, if you go to shop and ask, one rice I want. Will he give rice? Immediately will he give rice? And taking okay, so taking cover and taking a jug of rice and pouring inside of it, and will they give? No, he won't give like that. And so immediately we'll ask two questions. How many kgs you want? How many kgs you want, and for how much? For how many kgs and for how much. You will ask two questions, right? Immediately will ask two questions. Immediately will ask two questions. So the answer for how much or how many, the answer for how much or how many, okay, how much for or how many, and also it is amount, vastness or magnitude. It is amount, vastness or magnitude. It tells the answer for how much or how many. It tells the answer for how much or how many. How much or how many, right? So that is called quantity. That is called quantity. So coming to physical quantity. So physical quantity, physical quantity, physical quantity, physical quantity. Okay, physical quantity. So here the quantity which can be measurable, the quantity which can be measurable. Okay, so the quantity which can be measurable is called physical quantity. The quantity which can be measurable is called physical quantity. Example for physical quantity, the quantity. So the quantity, QUA. So the quantity which can be measurable, which can be measurable, which can be measurable. So measurable is called the quantity which can be measurable is called physical quantity. So simply I can say, so PQ I am taking each and every time instead of writing. So each and every time I am taking PQ. So it's called physical quantity. Physical quantity. Example for physical quantity. Example for physical quantity. Example for physical quantity. So example I am taking. So mass, okay, length, mass, length, okay, and distance, volume. So like that we can take. So all three things are covered. Like we can consider mass, length, distance, volume. So three things. The quantity which can be measurable is called physical quantity. So what is the physical quantity? It tells the answer for how much or how many, how much or how many, how much or how many. And here you can consider the quantity which can be measurable is called physical quantity. Example, mass, length, time, and time also we can say. And third one, so there are three types of physical quantities. There are three types of physical quantities. Three types of physical quantities. Three types of physical quantities. So three types of physical quantity. Okay. There are three types of physical quantities. What are those? First one you can say. First one, fundamental physical quantity. Fundamental physical quantity. Fundamental physical quantity. And the second one, there are supplementary physical quantity. Supplementary physical quantity. Supplementary physical quantity. And one more thing. So third one, derived physical quantity. Derived physical quantity. So once again, so how many are there? Quantity, the quantity which can be quantity means it tells the answer for how much or how many, or amount, magnitude we can say here. Magnitude or amount. So magnitude, So it tells the answer for magnitude, or amount or vastness, so and so on. Okay, it tells the answer for how much or how many. So we can say etc. Okay, physical quantity, the quantity which can be measurable is called physical quantity. So example, mass, length, distance, volume. And three types of physical quantities: fundamental physical quantity, supplementary physical quantity, derived physical quantity. So fundamental physical quantity, supplementary physical quantity, derived physical quantity. And next one, so we can go for fundamental physical quantities. So fourth one, fundamental physical quantity, I'll explain. Fundamental physical quantity. So you can see fundamental physical quantities. So here you can write fundamental physical quantities. So fundamental physical quantities are so first one, so it is a LMT stall. Fundamental physical quantities are LMT stall. Santosh, hi, and Stephen, hi, and one more. Who is saying? Still it is there. Jacob, hi. So next one. So fundamental physical quantities are LMT stall. So fundamental physical quantities are LMT stall. So L is the length. First one is L is the length. Second one is mass, and third one is time. So first one is length, second one is mass, third one is time. Okay, so next one we are going to the next one. Fourth one, strength of electric current. Strength of electric current. And fifth one, so thermodynamic temperature. Thermodynamic temperature. And so sixth one, amount of substance. Amount of substance. And seventh one, luminous intensity. So these are the seven fundamental physical quantities. So you can observe. So quantity is nothing but, so it gives the answer for how much or how many. So it's a magnitude or amount. Okay, magnitude or amount. So physical quantity, the quantity which can be measurable, is called physical quantity. Example, mass, length, distance, volume, like etc we can say. So etc, like so many are there. Okay. Next, three types of physical quantities. So there are fundamental physical quantity, supplementary physical quantity, and derived physical quantity. Supplementary physical quantities are length, mass, time, strength of electric current, thermodynamic temperature, amount of substance, and luminous intensity. So these are the seven fundamental physical quantity. Length, SI unit of length is meter. SI unit of length is meter. SI unit of mass is kilogram. SI unit of time is second. And the strength of electric current is ampere. So I'll write here. Just check once. Those are the seven fundamental physical quantities. 7 fundamental physical quantities. Okay, so now you can see length. So length I'm considering length SI unit is length SI. So this is SI unit, and here is a symbol. Okay. So SI unit is meter. So I am. And second one, mass I am taking. So kilogram, kg. And third one, time, second, yes. And fourth one, strength of electric current, strength of electric current, strength of electric current, ampere, strength of electric current ampere, capital A. Strength of electric current is capital A. And next one, thermodynamic temperature, fifth one, thermodynamic temperature. Okay, thermodynamic temperature, we can say Kelvin. Thermodynamic temperature. So Kelvin K. And the sixth one, amount of substance is mole. So we can say MOL. And coming to the seventh one is luminous intensity. Luminous intensity. Luminous intensity is candela CD. So these are the 7 fundamental physical quantity. Their SI units and symbols. Okay. So you can see. So maybe you can't able to see here, but you can see here, right? So length, mass, time, strength of electric current, amount of thermodynamic temperature, amount of substance, luminous intensity. So length is meter, symbol M. Mass is kilogram, kg. Time is second, S. Strength of electric current is ampere, a capital A. And thermodynamic temperature is Kelvin, K. So amount of substance is mole, MOL. Luminous intensity is candela, CD. Okay. So next one. So we are going to the next one. So these are the physical quantities. And next one you can see is system of units. There are a few system of units are there. So 3 system of units. Okay. So these are the fundamental physical quantities, right? Next one, supplementary physical quantities and derived physical quantities are there. So supplementary physical quantities. So we'll talk about supplementary. Now you can see supplementary physical quantities. So supplementary physical quantities. Supplementary physical quantities. Supplementary physical quantities. So here there are 2 types of supplementary physical quantities are there. One is plane angle. So here you can see unit. This is quantity unit. SI unit is radian. Okay, so rad, symbol is rad. And the second one you can see solid angle. Here is a solid angle. Solid angle. Solid angle is steradian. Steradian. Yes, sir. Okay, these are the supplementary physical quantities. So coming to the derived physical quantities. Derived physical quantities. Derived physical quantities. So derived physical quantities. So here these quantities can be derived from the remaining physical quantities. These quantities can be derived from the remaining physical quantities. Those are called derived physical quantities. So derived physical quantities. So example we can say density. So we can say example density. Example we can say density. Density, acceleration, acceleration, acceleration. Okay, density, acceleration, and velocity, velocity. So like that we can say. So derived physical quantities are the quantity which can be derived from the remaining physical quantities. The quantity which can be derived from the remaining physical quantity. Those are called derived physical quantity. Supplementary physical quantity means the quantity related to angles. Those are plane angle and solid angle. The SI unit of plane angle is radian. SI unit of plane angle is radian. Symbol is rad. So SI unit of solid angle is steradian. Symbol is SR. So this is the symbol. So whatever I am marking here, these are the symbols. So these are the units, SI units, and here you can see physical quantity. So derived physical quantity, the quantity which can be derived from the remaining physical quantity. The quantity which can be derived from the remaining physical quantities. So I hope it is clear to you all. Next one. So we are going to the next one. System of units completed. So system of units. Next one we are going to the dimensions. So dimensions I will explain. So how to find out the dimensions we'll see. Okay. So if you are taking the physical quantity, so physical quantity, the powers to be raised. So the powers in which physical quantity will be represented. The physical quantity will be represented. So okay. So fundamental physical quantities are there. Okay. So now I'm considering the physical quantities. Physical quantities. Okay. Now we can see length. Length dimension is capital L. So dimension formula is, if you are placing in a capital brackets, if you place, that is a dimension formula. Coming to the mass, so capital M. So I am considering a dimension formula is capital M. And coming to the third one, second. So second. So dimension is T. So we can take dimension formula capital T. Okay. So now with this we can take and thermodynamic temperature, amount of substance, and like that we can say. So remaining also we can consider. So with the relation of this, so what are the physical quantities are there? We'll discuss now. With this, what are the physical quantities are there? We'll discuss now. So I'm considering area. So area, if you consider area, I'm considering. So what is area? Area, if you take area. So what is area formula? What is area formula? Length into breadth. What is the area formula? Length into breadth. Length into breadth. So I'm taking dimensions. So L into L. So L into L, that is nothing but L square. So L square. So placing in capital letter, that is the dimensional formula of area. The dimension formula of area. So whereas volume, you see, volume if you are considering volume, so volume is equal to length into breadth into height. Length into breadth into height. So I'm considering length into breadth into height. That is nothing but L into L. Then you will get L cube. So the dimension formula is L cube. Coming to the acceleration, or we can take speed. So speed equal to distance by time taken. Distance by time taken. Here you can see M is distance, L I am considering T. So in the place of set of fundamental physical quantity. Set of fundamental physical quantities are length, mass, time. Set of fundamental physical quantities are length, mass, time. So with that, we have to represent set of fundamental physical quantities. So set of fundamental physical quantities. With that only we have to represent. So now I am representing with a set of fundamental physical quantities. Okay, so you can observe. You can observe now. So I am considering here. So I'm considering a length L and time is capital T. Length is L and time is capital T. So you can observe here. Okay. So that's why I'm taking L. So if you are writing in set of fundamental physical quantity, m power 0, L power 1, T power minus 1. So m power 0, L power 1, T power minus 1. Because so here if nothing is represented, if nothing is present, so power we have to take 1. So power we have to consider 1. So like normally if you are taking L, so T, M. So if nothing is mentioned, then powers you have to take 1. Okay, so powers you have to consider here. So here the letter is not there. So m power 0, m power 0 equal to L power 0 equal to T power 0 equal to K power 0 equal to theta power 0 equal to 1. Anything it will be represented power with 0. Power with 0 you are representing with 1. So power with 0 we are representing 1. That's why. So here this letter is not there, mass is not there, only a meter per second, only meter per second, that is length I am considering. That's why we are writing so L power 1, T power minus 1. So L power 1, T power minus 1. So this also we can write. This also we can write. So if you are instead of writing like this, we can also write. We can also write this one, or we can take L power 1, T power minus 1. L power 1, T power minus 1. Either this one or this one we can write. Okay, so because mass is not there, simply we can take up m power 0. I already said m power 0, K power 0, L power 0, T power 0. Anything if you represent, that is nothing but 0. That is nothing but 0. So simply I am considering m power 0, L power 1, T power minus 1 equal to, or that is nothing but L power 1 into T power minus 1. T power minus 1. I hope it is clear to you all. Next one, so we are going to the velocity. So velocity I am considering, that is also meter per second. So that is also meter per second. That is nothing but L by T. So L by T, L power 1, T power minus 1. So we can represent with that. So m power 0, L power 1, T power minus 1. So this is about speed, velocity, because so here only we can represent with the direction. So here velocity, if you see, only the direction is difference, remaining everything is same. Formula is same, dimension formula is same, units are same, everything will be same. Okay, so the difference between speed and velocity, so only the difference is direction. Between speed and velocity. So next one we are going to the next one. So you can consider force. I will write the dimension formula of force. See, if you want to write the dimension formula of any physical quantity, if you want to write dimension formula of any physical quantity, you must understand the formula. So force equal to, so what is the force formula? Force equal to ma. So m is the mass. So kg meter per second square. So you have to write. So force equal to ma. That is nothing but F equal to ma. So F equal to ma. So we can write F equal to ma also we can write instead of this one. So I am writing F equal to ma. So that formula is SI unit of mass is kg, SI unit of acceleration is meter per second square. SI unit of mass is kg, SI unit of acceleration is meter per second square. Now you can take, so capital M, capital L, T power minus 2. So m power 1, L power 1. So m power 1, L power 1. m power 1, L power 1, T power minus 2. m power 1, L power 1, T power minus 2. Okay, so here we have to write in this way. So if you write in this way, you will get the answer. So here m power 1. So mass is there. Mass dimension formula is m power 1. And so here length is L power 1. And here time is there. So if anything is there, 1 by T or 1 by T power 1 by T square or 1 by T power 1 by t cube. So we can write in this manner. So t power minus 3, t power minus 2, t power minus 1. Like that if you are writing, so it is correct. So now I am writing here. So 1 by t square is there, right? 1 by t square. So that one I am taking numerator. That one I am taking to the numerator. If you are taking to the numerator, huh. So okay, if you are taking to the numerator, m power 1, L power 1, t power minus 2. So 1 by t we can write t power minus 1, 1 by t square we can write t power minus 2. So like this we can write. Okay, next one. So we can go for work. So work damage formula. Can you write work damage formula? Work damage formula. Work damage formula is F into S. So we know F equal to MA into S. So MA is nothing but kg meter per second square. So meter, again meter, SI unit of distance is meter. Then we can write kg meter square per second square. Then we can write capital M L square t power minus 2. That is the work. Clear? Next one, linear momentum. Shall we go for linear momentum? Linear momentum. Linear momentum. So P equal to mass into velocity. P equal to mass into velocity. Kg meter per second. That is nothing but capital M L power 1 t power minus. Next one. So homogeneity principle. Homogeneity principle is nothing but, so left hand side of an equation. So the dimensions of left hand side of an equation are equal to the dimensions of right hand side of an equation. So that is called homogeneity principle, RHS. So if the dimensions of left hand side of an equation so are equal to the dimensions of right hand side of an equation, then that equation is dimensionally correct. That equation is dimensionally correct. That equation is dimensionally correct. This type of equation, this principle is called homogeneity principle. So what is the purpose of this homogeneity principle is nothing but to check the accuracy of the equation and to change the one physical quantity into another physical quantity and to obtain the relation between different physical quantity. To obtain the relation between different physical quantities. So next one, so we can go for significant figures. Significant figures is nothing but in a measurement. So the shore value, if you are taking 1 meter, 2 meters, or like that 1 centimeter or 2 centimeters, if you want to measure the length of this board, okay, so from here to here, if you are measuring, so we know up to 15 centimeter we know. So that measurement, so I'm taking here, so 1, 2, 3, 4 and 5, 6, 7 until 3 we can measure accurately. So below, so 3 point something, 3 point, so 2, 3 like that it is there, no. So this is the sure value plus and so approximate value, or those are these values are called significant. Sure plus, okay, sure plus and next digit, okay. So that is called significant figures. So rules for writing the significant figures. So all non-zero digits are significant figures. First one, all non-zero digits are significant figures, are 3, 1, 2, 6, all non-zero digits are significant figures. And the second one you are taking all zeros are occurring between the non-zero digits. So 2, 0, 3 are this. Here I am taking 4. Here also 4, because all zeros occurring between the two non-zero digits are significant figures. And the third one, if you are considering all zeros occurring between the last last non-zero digits. So this is not significant figure. So zeros occurring between the right side of the last non-zero digit, this is not significant figures. Only significant figures are 3. And coming to the fourth one, in a uh, number, in a digit less than 1, so 0.00234 in this number, after decimal point and left of the non-zero digit, after decimal point right of the so in a digit less than 1, in a digit less than 1, right of the decimal point and left of the non-zero digit, these two are not significant figures. And the last one, in a decimal point, the zeros occurring in the last non-zero digits are significant figures. So 1, 2, 3, 4, 5. So 5 significant figures are there. Once again, so all non significant figures, sure value plus next and doubtful digit. So those are called significant figures. So significant figures here, all non-zero digits are significant figures. Once again, all non-zero digits are significant figures. And second point is all zeros occurring between the non-zero digits are significant figures. All non-zero digits are significant figures. All non-zero digits are significant figures. All zeros occurring between the non-zero digits are significant figures. So all zeros are occurring in the in the right side of the non-zero digits. So those are the this is not a significant figure. In a digit less than 1, right side of the decimal point and left of the non-zero digit, these two are not significant figures. Only this we are considering. And in a decimal point, in the right side of the last non-zero digits, if zeros are occurring between the right side of the last non-zero digit, then these are significant figures. These are the significant figures. So here significant figures are 5. So these are the rules for writing the significant figures. Next one, we can go for rounding up the number. So to get the desired value, we'll do modifications in measured value. To get the desired value, we'll do modifications in the measured value. So if I'm considering 3.64, so if it is followed by less than 5, so here in decimal point last digit, so followed by more than 5, and this digit is less than 5, then we can write so we should not do anything, we should not raise 1, we have to keep it like that only. And coming to the next one, so if you are taking 3.69, so this is more than 5, so whatever the value it is there, that is more than 5, so more than 5, then we can say, so 5 is like the, so 9 is greater than, right? 9 is greater than. So I'm considering here 9 and here. So 9 is greater than the 5. So that's why we have to raise the value to the next number. And coming to the third one, so if you are taking 3.55, so then we have to rise up to the next value. And the fourth one, so the fourth one, if you are considering 3.750, so here you can see last number is 0, last number is 0, last number is 0, and it is followed by, it is odd number. If it is odd number followed by 5 and it is odd number, we have to rise to the next number. We have to rise to the next number. And coming to the fifth one, if it is 3.650, last number is 0, and after the decimal point, if it is even, means we no need to rise, we have to write like that only. We have to write like that only. If it is odd only, if it is odd only, we have to rise to the next one. So if it is even, we no need to rise, we have to keep it like that only. So these are the, so what are this one? Rounding of the numbers, rounding of the numbers, rounding of the numbers. So errors are 4 types. So the lack in accuracy of the measurement, the lack in accuracy of the measurement. So due to limit of accuracy of the instrument, due to limit of the accuracy of the measurement. So there are 4 types are there. 4 types are there. So absolute error, mean absolute error, relative error, and so percentage error. So there are errors are types. Error is nothing but error. So how it will get error? So error you can see error. Okay, so errors. So what is the error? So due to lack in accuracy, due to lack in accuracy in the measurement of and in the measurement of an object due to the limit of accuracy of an instrument. Only see up to 1 meter, up to 2 centimeter, up to 3 centimeter, up to 1 kilometer, like that only it can measure. So more than that it won't measure due to limit of accuracy of an instrument, or other reasons also, errors will occur. So there are 4 types of errors are there. So one is absolute error, one is absolute error, and the second one is mean absolute error, mean absolute error, mean absolute error, mean absolute error. So here, next one, mean absolute error, and third one, relative error, and fourth one, percentage error, percentage error, absolute error, mean absolute error, relative error, and percentage error. So these are the 4 types, errors 4 types. Okay, so once again, error is nothing but the lack in accuracy in the measurement of an object, or a measurement of an object due to limit of accuracy, of an instrument, so measuring instrument. So that is, so errors are 4 types: absolute error, mean absolute error, relative error, percentage error. So absolute error, if you are considering, absolute error is nothing but the difference between true value and a measured value. The difference between true value and measured value. Absolute error is nothing but the difference between true value and measured value. The difference between true value and measured value is called absolute error. So mean absolute error is nothing but the arithmetic mean of magnitude of absolute errors is called mean absolute error. Relative error is nothing but so mean absolute error by true value, mean absolute error true value. So relative error can be, so if you are writing relative error in the form of percentage, that is called percentage error. So that is called percentage error. So these are the types of errors. So these are the types of errors. I hope it is clear to you all. So if you have any doubts, you can ask. So otherwise, we'll see in the next class. Thank you so much.